Hey everyone, this is the first video in a series of videos that I'm going to make that are going to follow along with building a jet engine. And I'm not going about the typical way of building it, which you use a turbocharger with a centrifugal compressor. I'm going about it completely on my own, everything custom made. We're going with an axial compressor. So I've done a few tests. I've got this laser cut, just a 10-inch diameter circle out of 304 stainless at 1/8 of an inch thick. And I'll show you what I have done so far, and I'll explain where I'm going with this. So here I have my test rotor. I got the circle diameter laser cut to 10 inches. So I decided that while I was waiting for the laser cut version with all the all the blades laser cut and the holes and such, just so it was perfect, and the tolerances were a lot closer than just cutting it with a hacksaw like this one, I decided that I would test, well, first of all, cutting, which I won't be doing myself, but I wanted to test it anyways. So cutting, and then also bending. And this is an 1/8 of an inch thick, so 0.125 inches thick, and it's 304 stainless, so this is heavy stuff. This was not easy to bend. And one of the things I learned from bending this test piece, I'm definitely going to need a tool made to do this, because I was using a 4-foot long pipe and attaching it to this surface and then bending, and that's how I got that. And that's not reproducible. I can't use that over and over again to bend a perfect angle for every blade. As you can see, these two are actually different blades. I did a test. This is the first stage blade. The blade length is a little bit longer than the second stage blade. Second stage. So I still have to make a third stage blade, but I think I'm gonna give it a little space and do it somewhere over here where it's not interfering with any of these blades, so I can test out the bending a little bit more accurately. Just because, well, with this one I'm not too sure how accurate this bend actually is, because this cut is actually 1/2 an inch deeper than this one, which is what it's supposed to be. So we'll see about that. This is my third stage. The blade lengths are 2.5 inches. Stage 1, the blades are 3.5. Stage 2, blades are 2.5. No, I don't think that's right. I gotta look at my drawings. Okay, stage 2 is 3 inches, and then 3.5 for stage 1. So it is over the span of the inlet to the compressor exit, we're talking 2.5. What is that? Brain's not working right now with the math, but it's a good chunk. It's about this much for the exit, so that's a bit of a difference. Calculated that the actual compression ratio for the engine, well, in a perfect world, perfect conditions, it's going to be somewhere between 1.8 and 1.2 to 1. So it's okay, I guess, for only doing 3 stages, but we'll see what we can actually get. Now I've got another disc here. I haven't done anything to it, and I don't know if I'm even going to do anything to it, because the laser cut first and second stage completed, minus bending and airfoil. They said they'd be ready tomorrow, so these two pieces pretty much beyond today are really just going to be used for testing, and in addition to the bending, I attempted to do an airfoil. Now this is the leading edge. If I can get this to focus. It's not perfect, there's a little nick there in the front, but it's actually pretty damn good. I mean, I used 400 grit and 100 grit sandpaper, and then first I filed it, but running my nail along, there's no nicks or dents or pits, so it's pretty perfect minus this little thing here. And then I smoothed out all this here, so it's actually pretty nice, and it seems like it's going to work pretty well. So we'll see tomorrow, but unfortunately getting the bending tool made, which my lovely diagram, this is a blade, and this tool basically just grabs onto the end of the blade, and then in that hole there stick a big pipe, probably about 4 inches, 5 inches, no, not 4 inches, 4 feet long, and then twist it, and that should work. I'm gonna have to get one made for each stage though, because the length here needs to be pretty much the entire length of the blade. So as you can see, this is considerably larger than this, because stage 1 I believe is a 30 degrees in terms of center and blade, because there's only 12 blades in the first stage. Second stage is 24 degrees and there's 15 blades, and third stage is going to be third stage is 20 degrees, and I believe well, 24 blades. Actually, that's not right. I don't know, but it's 20 degrees. So I have to write all this down. But so far so good. I mean, pretty smooth. This side though, this is going to be the difficult one. I tried filing along here to get the trailing edge. That's going to be a difficult task. I'm not too sure what I'm going to do about that. I want to try to avoid using power tools for the sanding and grinding, just because, well, it could take too much off, and blade consistency is definitely important. So what I might have to do is use a power tool with a very fine grit piece and use a micrometer to try and do my best. That's going to be, it probably will end up being just as tedious as using like a little file like this, like I was using for the leading edge. It's actually pretty perfect, and it took pretty close to, I'd say pretty close to an hour to do that, just that one leading edge. So you're talking a lot of hours just on leading and trailing edge filing for 3 stages, and that's not even including stators that need to be made that are going to go between the stages. So that's where I'm at so far. Yeah, I'm not sure what else to show. Don't really have any other pieces yet. I've got the stators, or sorry, spacers designed. Just got to find a company that can do the metal rolling. So with that being said, the first task is obviously the compressor, because if I can't get a working compressor, then there's no point in really making any more of the engine. So with the testing I've done, it looks pretty promising. So we'll see what we can get in terms of results from the laser cut first and second stage compressors with the bending, and then obviously we'll work on the leading edge first because it's the easiest. I'm not too sure what we're going to do with the trailing edges of each blade. So we'll do that first, and then we'll see. I'm also getting tools made to actually make the bending easier on the center part, because obviously you've got a piece in the center that's not going to have any bending done to it, and you actually don't want any bending. So just maybe, I think it's going to be, the guy's making it, he knew exactly what I meant, but it's going to be a half circle and a little bit of an extra bit here, because there's going to be a 1/2 inch diameter hole in the middle of this. It's only for air. There's going to be no no bolts there. There's going to be 8 bolts within this 3-inch diameter circle in the middle. For stage 1, stage 2 is a 4-inch, stage 5 is 5. So 5 is about, it's going to end up being about half. So tools being made to make it easier, because I actually, going along the edge of this imaginary middle circle here, I can feel a little bit of deformation, and that shouldn't happen, because obviously that'll put it out of balance. But if you do it perfectly throughout, it won't really matter. But again, if you're attaching a flat flange, which for the spacer to go in between the two, that face has to be flat, because that's what gets bolted to it, and air should not be leaking there, or else you're going to be losing some performance. So first we're going to worry about the compressor rotors, first and second stage. Then we're going to move on to building a compressor case and the inlet, which is going to hold the front bearing housing, which that should be fun, because, well, if that's not perfect, then the engine's rotational axis will be out, and bad things will definitely happen. So we'll see how the results of the compressor rotors go, but I'm going to try to work on this weekly, but I can't guarantee that, because this is not the only thing I have going. So, but I'll try and update this as I work on major things. I'm not going to worry too much about recording leading edge filing. I may make a video on it, trailing edge filing, stuff like that, but this is more going to be a progress series. Probably end up going into some of the stuff, like when we do bending for the first time, I'll record that just to show how that process works and the tools that were made for it, just to make it easier. But yeah, so next video actually will probably be pretty soon, because I'm gonna it'll be a short one, but I'll be showing the results of the laser cut first and second stage compressor rotors, just so we can see them before any work is done on them. And actually, one thing to note, that even though this is a lot of work to do just one of these, the actual material and the cutting itself was relatively cheap. It was under $20. So if I mess up, it's not a huge deal, at least with the compressor. You can just order a new one. But if I mess up on the turbine, which it's going to be Inconel, that's going to be a $300 mistake on a rotor this size. So for this, not a big deal, but we'll see. And yeah, so I will be posting another video pretty soon, within a couple of days, and thanks for watching.